Hi, let us understand what role vector, matrix, and dimensionality reduction plays within the machine learning. Already we have seen different type of machine learning algorithms like supervised and unsupervised learning. In all this learning, we will be using a mechanism called training the data as well as testing the model and generate the model and store the model. Of course, you may have a question how the data will be used within the machine learning. The data could be a structured data or unstructured data. If it is unstructured data, how machine learning going to handle? Let us see with the example. Any data that I have, we should have a mechanism to represent that in a mathematical form because computer systems can understand only numbers. And I'm going to find the relation between that particular mathematical form we are using to represent any unstructured data. Let's start with the vectors. As a human being, I can visualize only 3 dimensions. For the best understanding purpose, let us consider a 2-dimensional data. Let's assume this is going to be the age and this is going to be the salary. So I have a 2-dimensional space where any data I need 2 dimensions to represent. Let's say I have a data where age is say 20 and salary is let's say 5k. Now another data point, let's say age is say 40 and salary is 10k. And let's assume another data I have where age is 38 and salary is 12k. Now visually we can see these two data are somewhat related because the distance between these two data points is less. And the other point where let's assume I do have another data point 22 and salary as 6k. So these two data points are related and the other two data points are related because the distance between these two data points is less. How to find the distance? In any vector I can find the distance. So mathematically I can find the distance between these 2 points as well as the distance between the point which is having age is 22 and the point which is having age is 40 where it is more. And there are n number of ways to find the distance, Euclidean distance or cosine distance. There are n number of ways. Let's not worry about that. Let us leave that to the data scientist. Now in 2-dimensional space I can find the distance between these 2 points. Let's introduce another dimension. I'm going to introduce another dimension, say savings. So with this particular dimension, for every point I need to know what is the savings. So if I have the savings, I can represent that in the 3-dimensional form. As a human being, we can visualize only 3 dimensions, but computer systems can handle n number of dimensions. So what I will be doing, I will be representing each and every point. Let's say I do have a record 1 where I do have the details like salary, age, savings, number of children, number of vehicles, amount insured. So here I do have 6 dimensions. Like this I can have millions of records. So what I will be doing, each and every record I will be representing that as a vector which will be having 6 dimensions. And all these vectors together will form a matrix. So I will be having a matrix with n number of records and each record will be having 6 parameters. Let's assume these are the 6 parameters I have and what that particular value I don't need to worry about. Like this I will be having million such records. So I will be having a matrix with a dimension 6 multiplied by 1 million and all calculations will be based on this particular matrix. Now let us understand where dimensionality reduction comes into picture and what its importance. Considering all these points together and doing the mathematical calculation, it's going to consume huge amount of CPU as well as memory. So I need a mechanism to represent the data with less dimensions without losing the features, without losing the details. That is very similar to how do I have the images compressed together. I may have a 1 MB text file or image. What if I compress it? The size is going to get reduced, maybe 200 KB. The size is less, but whenever I want, I can get the same 1 MB by decompressing it. The same way, any data, what I can do, I can represent that as a function. So what I will be doing, assume I have a data, let's say I have data like 2, 4 and another data point like 4, 8 another data point, say 10, 20. Now what I can do, I can represent this as a function. Y is equal to x multiplied by 2. So whenever I wanted to calculate the y, I need to multiply the x by 2. This is a very simple function. Now any data I can represent that with reduced dimensions so that the calculation will be much easier. Let's say in a three-dimensional space, x, y and z, I have two cylinders. What I can do, I can consider only the x and y where it will be looking like a circle. And I can consider z and y where I will be considering only the height of those circles. So for calculation purpose, I will be considering only the minimized dimensions, do the calculation, then I should be in a position to merge those data. And mathematically that is possible. There are n number of dedicated algorithms to reduce this dimensionality. We call that as a dimensionality reduction. Within scikit-learn library, we do have a dedicated number of algorithms for dimensionality reduction like PCA and n number of algorithms. And you may be having a question, how unstructured data will be handled. Let us see in detail about how to handle unstructured data within the machine learning in the next lecture.